Question 34 of the Algebra 2 Mixed Review packet. The expression parentheses 2 plus 3i close parentheses squared is equivalent to. We could rewrite this. Since it is an exponent of 2, that means that this factor is multiplied by itself, and that factor appears twice. So this is the same as 2 plus 3i times 2 plus 3i, which can be used with double distributing or foiling. First, we're going to multiply 2 by 2 to get 4. Then the outer term would be 3i times 2, which is a 6i, positive. Inside is 3i times 2, which is positive 6i again. And then you have 3i times 3i, which is a positive 9i squared. Combine the middle terms to be 12i. And then what we're going to do is we're going to trade out the I squared. Remember that the I squared is equal to negative 1. This is going to be 4 plus 12i, and then 9 times negative 1 is minus 9. The last thing you could do is combine the constants. 4 minus 9 is negative 5, plus 12i. Question 36. The value of I to the 16th power is equivalent to. And remember, we could always take the power and divide by the 4 options of the powers of I, and then you get 4. The remainder is 0, which tells us that I to the 16th power is equivalent to I to the 0th power, and anything raised to the 0 power is equal to 1. The final answer is 1. Next question is 37. The discriminant of a quadratic equation is 24. And remember that the discriminant would be found in the quadratic formula, and the discriminant would be b squared minus 4ac. So that's equal to 24 here. We'd like to know what type of roots those would be. Choice A is imaginary, and that would only be if there's a negative discriminant. However, we're looking at a positive discriminant of 24. And it's important to realize that it's a positive number, so it has to be a real root. But also that it's a non-perfect square. And it's also not equal to 0. So when the discriminant would be equal to 0, the roots would be equal to each other. So it can't be choice B here. So we're down to choice C or D, which both of them have real and unequal roots, but the difference would be whether it would be rational or irrational. Since there's a non-perfect square discriminant, the roots are going to be irrational. They're still real, but they're irrational. That's whenever the discriminant is a non-perfect square. Therefore, the best choice here would be choice D, which is real roots, but they are rational roots and they're unequal to each other, meaning that there are 2 different roots. And question 39 is your last question of this section. I'm going to hold this question under the camera. In the accompanying diagram of the graph of the parabola y equals ax squared plus bx plus c, which must be one root of the equation? And we know that the roots can be, the real roots can be seen as x-intercepts, so negative 1 is one of the roots, and the other x-intercept is 3. Negative 1 and 3 are both roots, and those are the real roots. Therefore, choice C would be the way to go, since negative 1 is not one of the choices.